Brooklyn in the house. Welcome. Everybody hear me? Welcome. Did you hear that? There you go. Brooklyn in the house. This is... Thanks for coming out and giving us your Friday night. This is a special presentation of StarTalk at BAM. And in this presentation, you're going to get 3 versions of what our StarTalk franchise is all about. The first one, lasting 30 minutes, is StarTalk. StarTalk flagship, all right, where I am the host, and we have special guests talking about special topics. We then go to another 30 minutes featuring StarTalk All-Stars. And that's where we have a cadre of counterparts to me who are experts in other fields of science. And they each have their own sort of radio show with a comedian, similar format, but they get to do it their way. StarTalk All-Stars, you'll get a sampling of that for 30 minutes. And then we will end with one of our favorite new franchises of StarTalk Playing with Science, which is all about the science of sports. And tonight, we're going to talk about the physics of figure skating. And we'll get back to that in a minute. But right now, we will begin StarTalk at BAM. I'll bring out my comedic co-host, the one, the only Chuck Nice. Come on out.
What's up, buddy?
Oh, man.
How are you, man?
This is my man.
It's good to see you.
Very cool. And so tonight, we're going to talk about the physics of the early universe. Ooh. And I realized this whole event was introduced as a radio love fest, but he didn't say it right. You got to say a radio love fest. you got to do that right.
Yeah, exactly. I think you just made the universe pregnant.
Love fest. Let me introduce a colleague and a friend, one of the smartest people on Earth, theoretical physicist, Brian Greene, everybody. Brian Greene, best known for sort of popularizing concepts like string theory and the multiverse.
You just made string theory pregnant, man.
Your best-selling author, The Elegant Universe, a beautiful book. Give it one. That person read your book right there. That person read your book.
I know the rest of you are just posers.
So that was followed with Fabric of the Cosmos,
yep.
A beautiful book. Hidden Reality was a third book. And then you are a co-founder of the World Science Festival.
That's right.
Co-founder. It's a bit audacious to call it the World Science Festival.
Well, we're going to call it the universe, but, pulled it back to world.
No, it's just great. It's a World Science Festival held in New York. I'm just saying.
Also in Australia, so it is world in that way.
Okay, all right. And co-founded with your wife.
That's great.
Very good.
Smart man. Very, very smart.
How to keep that marriage going.
Yeah, there you go.
So, Brian, there was recent news of the earliest star ever formed in the universe.
Yeah.
So were you on top of that story?
Been following it, yeah.
Yeah, because what we know as astrophysicists is you get the Big Bang, got that, okay? Then you have the cosmic microwave background, got that. But nothing's formed yet. You got to make stuff that you can recognize in modern times, and there's this long period, hundreds of millions of years, where nothing is happening. And so we call that the cosmic dark ages. Yeah. Got to say it right, dark ages. And so, let me hear dark. Yeah.
Dark.
Yeah, there
ages.
you go. How you give him a B+?
I'm going to give him a B+.
Okay.
I'll work on it.
So the dark ages, before the first stars had formed. So there was the hunt, the eternal hunt. Can we find that first star? And a recent news announcement said what?
Well, there's now evidence that those first stars may have formed about 180 million years after the Big Bang. And it's hard to find them because they're not actually sitting out there waiting for us to see them directly. You have to find an indirect test to see their presence by virtue of their impact on their environment. And in a very clever experiment, that's what was done.
And how'd they do that experiment?
Well, you mentioned the cosmic microwave background radiation, right? Just people know what that is. It's just here, yeah.
No, I mean, even if, listen, because, there are some people like at home listening that may not know. So, I'm just saying, for their sake, maybe you should tell them.
Okay.
So this is heat left over from the Big Bang. The Big Bang's very hot. As the universe expands, it cools down, but the heat doesn't disappear. It's still there. And indeed, we can see that heat coming to us through powerful satellite-borne telescopes today. Now, that is a fantastic discovery in its own right that won the Nobel Prize, the discovery of the microwave background radiation. But now imagine this.
It's won the Nobel Prize twice.
That's true. Yes,
Yeah.
absolutely. Yeah, the initial discovery and then a more
and the
refined version.
I got to tell you, that's very good.
Yeah, the
same thing, just like 5 years later. Oh my God, that was so. We should give it to him again.
Give it to him again. Right. So, no, it was a badass thing we found in the universe.
Yeah.
Okay.
And it was found by mistake.
Mistake, yeah.
Right? Oh, so you do know about this, man. You said mistake before I did.
Oh, I didn't mean to.
So, how did the cosmic background tell us this?
Well, the theory was that when these initial stars formed, they would be very large, much larger than the sun, and very hot, and they would have emitted a lot of ultraviolet radiation. And that radiation would have had an impact on the environment. A lot of hydrogen around it would have ionized the hydrogen. Why does that matter? When you cause the hydrogen to change in that way, it has an impact on the microwave background radiation that otherwise would have passed through it.
Passed through it with no incident.
With no incident.
And now it's been perturbed.
That's right. Now, actually, some of it gets absorbed, which means when we look out, there should be missing parts of the spectrum.
Okay.
That are being absorbed by this hydrogen, which itself is being affected by these early
So we're not
stars.
seeing the stars themselves. We're seeing some kind of smoking gun of the stars.
Yeah, we're seeing a shadow, in some sense, of the stars.
Oh my God, it's just like the Russia investigation.
So Chuck, I didn't tell you the reason why we have such Big Bang expertise is because we have both independently appeared on the Big Bang Theory.
That's true, actually.
Actually, I was only on once. Were you on once?
Only on once, yeah.
Oh, they didn't invite you back?
No, they didn't.
Yeah, they didn't invite me
How
back.
about you either?
Yeah.
Welcome to my world.
But I thought you did really well.
I thought you did really well.
I'm so not an actor. And I depend on people allowing a little latitude for that cameo, non-actor delivered lines.
Yeah.
You know? You say, okay, they're not really an actor, but we'll let it slide. You were good.
Well, thank you. I appreciate that.
And plus, Sheldon gave both of us a hard time.
He did.
Right.
He told me that I should give up physics and consider reading to the elderly. But he said, don't read your own books to the elderly.
Yeah, he was pissed off that I was an accessory to the demotion of Pluto.
Oh, Pluto, yeah.
Yeah, he said Pluto was one of his favorites.
And you told him to get over it.
Yeah, to get over it. Yeah.
Yeah.
But but he scripted to just get angry, so he just got angry.
Yeah.
Yeah. I couldn't rely on a natural response.
That's because he's not real.
So Brian, this early star, does it tell us something backwards towards the Big Bang that we should know about?
Well,
Because you're a Big Bang guy.
yeah, it does. I mean, the curious thing is that the signal is stronger than the theory predicted. So the signal's there in the sense that you've got this missing part of the spectrum.
So you had people saying, what would a first star look like? Let's map it out.
Yeah.
Now you compare it, and now we got something stronger than that.
That's right.
So that means you got to go back and recalculate what?
You've got to tweak the theory, and people are suggesting that dark matter may play
See how we did
a
that?
key role.
Got to tweak.
Tweak.
Yeah.
Right.
So I don't know what he's cooking up, what he just tweaking stuff.
But the tweak also kind of spilled over into the dark matter, so I'm not sure what this means.
Okay.
I don't know what either of you are talking about. That's fine.
Okay, so what of the Big Bang do you have to tweak in order to allow our hypothesis to match the observation?
Well, it may be that the dark matter interacts with ordinary matter in a way that differs from the conventional description. This is very speculative. We're right at the beginning of this kind of an experiment.
At what point do you say, I need to tweak my theories? And at what point do you say, I need to throw out my theories?
Well, that's the art. That's the art of science, And, some people criticize scientists for sticking to theories long after the data seems to suggest that they really need to move on. People say that even about string theory. They're wrong. But yeah, so it's an art and it's a personal choice.
To his face, just to be clear, because I'll say this again publicly, but I did really say this to his face.
Oh, snap.
When I asked Brian, I said, Brian, I remember y'all, I'm that old, from the 1980s. String theory was being born, and I said, wow, this is great. A new understanding of the universe, general relativity married with quantum physics, a marriage that Einstein died trying to find. How soon will you have this? He said, we're about 5 years out. About 5 years. And then 10 years later, how far? Well, we did another 5 years. And then 10 years after that, just another 5 years.
I'm consistent. Hey,
wait. So then it's like the year 2018. Brian, how about...
About 5 years, I'd say, something like that.
How close are you to this? And it's like, so then I said, so Brian, why? He said, well, it's a hard problem. So then I said, or... every one of you working on this problem is an idiot.
He did.
I said that to his face.
Brian, I'm going to go with hard.
No, at what point do you... No, I said that, jokingly. At what point do you say, we're simply not smart enough to even answer the question we ourselves posed?
Yeah.
Or do you just say it's hard? Because Einstein figured out general relativity basically by his lonesome in 10 years after he had special relativity.
Yeah.
And you got how many dozens of you guys? And
yeah.
For 35 years.
Yeah. Well, look, I got to tell you, the reason I accepted to be on the show tonight is...
Okay, what?
I'm finally willing. No, here's the situation. If we were not making progress, then I wouldn't need you to tell me to give it up, right? I don't believe in reincarnation. I think you live once, and I don't want to spend my life working on a theory if I really don't think it has the promise to reach the goal that we have set for ourselves.
So you're honest with yourself.
I'm totally honest. But
we have so much in common, because I don't believe in it, because I don't want to be a turtle.
Okay.
No, you said I don't believe in reincarnation. For some reason, I think I'm coming back as a turtle.
I hear what you're saying. Yeah, I got it. Yeah.
Yeah, we both missed that.
Went like this.
Yeah. Yeah, and you're the astrophysicist.
We both missed that.
Because they got it. Go ahead.
But here's the thing.
They did not get that.
Oh, they got... Did you not get that?
I was thinking...
Stupid people unite!
No, I was thinking the turtle was a reference to sort of the Hindu on the back of an elephant, and the elephant standing on turtles, and his turtles all the way down.
See, that's why you got doctor in front of your name. And I tell dick jokes.
So...
Where were we?
But I know exactly where we were.
I'm sorry. Go ahead.
I know exactly where we were. So what I'm asking you, as a theoretical physicist, leading theoretical physicist, we have an observation, an astronomical observation, and it forces you to go back and tweak. Are you tweaking Big Bang? You're tweaking quantum physics? You're tweaking... What are you tweaking?
Well, in this particular case, you really are tweaking something that we yet don't understand fully, which is dark matter. So that's ripe for being tweaked. But look, there are other things.
Dark matter is like mysterious gravity of the universe. We have no idea what's causing it.
But I'll give you another example, which has happened recently, right? There have been measurements of the rate of the expansion of space. And those measurements, very recently, are seeming to be incompatible with earlier measurements done in a different way.
This yet a whole other recent result.
A whole other recent result, exactly. And this one, if it's correct, this is one that could really change our understanding of the early universe dramatically, right? In order to get the measurements that are done on the expansion of space looking at the microwave background radiation and those that are coming from looking at supernova explosions, to get those compatible right now is going to require perhaps tweaking the dark energy. It may require tweaking our understanding of the gravitational force. I mean, there are many things that may come into that particular reconciliation.
Our understanding of the gravitational force itself?
Yeah, I mean, whenever you talk about dark energy, right? Everyone knows what dark energy is? Yeah?
No, well, I'm just saying, some people at home may not.
Right. So this energy filling space that we believe yields a repulsive gravity that's causing the universe to speed up in its acceleration. And
When it theoretically should be slowing down.
That's right. Ordinary gravity pulls things together. It should
Right.
be slowing down.
Okay.
The shock that we got in 1998 is that it's not slowing down in the rate of expansion. It's speeding up.
Against the wishes of gravity.
And well, here's the thing. We didn't understand gravity well enough. Gravity can not only be attractive, it can be repulsive. And that really wasn't taken into account until about 1998 when it comes to cosmology. Now, the possibility is maybe this outward push is itself getting stronger over time.
And so that means thinking it was one thing would be an incomplete understanding of that phenomenon.
Yes, and
Which
that's
would
what science
actually
is.
change everything.
But that's what science
Which is why
Yes.
you have to tweak string theory.
Yeah.
All right, so if it affects gravity, then every moment of our models from the Big Bang forward would have to be rethought, put back in the computer, say, now what are you going to give me with this new understanding?
Literally, because these equations are so complex, there's so many features that come into play that you have to put it on a computer and simulate and see what happens.
Okay, so now, does that affect any thinking of what's going on before the universe began?
Well, I mean, people play with those sorts of ideas, but it's hard to know if that question even makes sense, right? It makes sense to say what happened before you were born, what happened before the Earth formed. Those sorts of phenomenon certainly were preceded by something else in the universe. But the Big Bang may have been not just the beginning of the universe as we think of it as stuff. It could have been the beginning of time itself.
This past Sunday, we aired my interview with Stephen Hawking. Went to the dude's office in Cambridge. And I asked him what was around before the Big Bang. He gave an answer, and nobody understood the answer.
Yeah.
So now, you check it out if you don't get. So
I have no idea what he was
What was he saying?
I have no idea. I haven't seen the podcast.
you got to watch the show.
Yeah, I will. Yeah, you didn't prep me on this one.
All right.
But
No.
Allow me
some
to
thoughts.
explain what he was saying.
yeah.
But you can give me 2 or 3 ideas that people
Yeah.
have about what preceded the Big Bang.
Absolutely. So
Whether or not they're your ideas.
yeah,
You just-
one idea is that the Big Bang may not have been a unique event. There may have been many Big Bangs, giving rise to many universes.
We are one of those
and
universes.
we're just one of those, sort of like a cosmic bubble bath of universes, and we're just one bubble expanding in that larger landscape of reality. If that's the case, then our Big Bang was not the beginning of everything. It was just an interesting event that we hold dear because it gave rise to us. But there would have been a time before it that wouldn't have been any more exotic than the time now.
a time measured by some methods we have yet to divine, because every method of measuring time exists within this universe.
That's right. So the notion of a time going across all of the universe is a very difficult idea to make mathematical sense of.
Like a meta time.
A meta time of some sort, but people don't fully appreciate.
But that wouldn't be time.
It wouldn't be
That would
time
not
as we
be time.
experience. You're
Right.
absolutely right. You're absolutely right. So in this universe, the fact that we can say that the universe has an age of whatever, 13.8 billion years, is only because our universe is highly symmetric. You look at one chunk of the universe over here and another chunk over here, and on average, their properties are the same. And
So
if that weren't the case, there would be no notion of time across even our universe.
Because of this symmetry of appearance, you're saying, we can justifiably say we are all experiencing the same age of this universe.
That's right.
But if we looked over there and stuff was being born, and over here stuff was dying out of proportion,
Yeah.
we would be forced to say there's not one coherent time across the space-time continuum.
Right. You see, because Einstein, as we're all familiar with, taught us that if you're moving, time ticks off at a different rate. If you're near a black hole, time ticks off at a different rate. So you should ask yourself, when people say the universe is 13 billion years old, according to which clock? Right? If those clocks are moving, or if they're near a black hole or a strong gravitational field, they'll tick off time at different rates. And the way we get out of that conundrum is what you're saying. The overall uniformity means that on those clocks that are experiencing basically the same physical conditions, they're going to experience time the same way.
I loved your clock pantomime.
I love it too. Man, I have never in my life wished that I smoked weed more than I do right now.
So,
now I know why they do it, man.
So, we got to land this plane. So, two final questions. So, if we're asking what was around before the Big Bang, you say maybe there was this bubble bath of Big Bangs, then that just pushes that question a little further. What was around before the bubble bath?
Or it may push it infinitely far back. That's a possibility.
Turtles all the way down.
So it could be turtles all the way down.
But
the other idea that does come out of string theory initially is that maybe our universe is a slice of space floating in a larger cosmos, right? Higher dimensions of string theory allow for that freedom. So our universe is like a slice of bread in a big cosmic loaf that may have other slices, which would be other universes. I bring that up because there's a theoretical description. I'm gonna ignore these guys. So there's a
We were good at it. Now we're like slices of bread. Okay.
All right, here.
Now slice of bread. I got you.
All right.
With this, the bread loaf universe.
Exactly.
Go.
And there's a way of describing the Big Bang where it's actually arising from the collision of these two universes. It's no longer called the Big Bang, or it's called the Big Splat, right? So it's a little more evocative way of thinking about it. In which case, before the Big Bang, before the Big Splat, would just be these two giant sheets of space slamming into each other.
And they create a subsequent Big Bang.
That's right. It's a cyclic universe. It happens over and over and over again through these collisions. So then what's before our Big Bang? It would just be an era of the universe similar to this potentially, but was just a different part of the cycle.
So therefore, and my last question to you, the very distant future universe, where we're accelerating at whatever rate it is, does what you're saying now affect that very distant universe?
It can, absolutely. Because if, for instance, we're talking about a cyclic universe...
No, but my slice of bread is getting bigger.
Your slice of bread is getting bigger, but that other slice may be coming toward you. So 1 trillion years from now, we may get hit again and be completely obliterated.
How will we know if another slice of bread is coming towards us?
That's the thing, we won't.
all I know is I am hungry right now.
Well, Brian Greene, thank you for totally fucking with our heads here tonight.
Yeah, man, that's
Brian Greene.
That's awesome stuff, man.
Thank you.
It's phenomenal.
So hang on for a second. So we're going to wrap up this part of the show before I hand the baton over to neuroscientist Heather Berlin, one of our StarTalk All-Stars. And while she comes out, but before that happens, we are going to have a special musical interlude.
Oh.
Musical interlude.
Oh, sweet.
We are going to have a special performance by Baba Brinkman. Baba Brinkman, come on out!
All right.
Baba, you're a science rapper.
I am a science rapper. Such things do exist.
That's the thing.
It's a thing now.
You will demonstrate that now.
Let's all hope so.
Baba Brinkman. All right.
All right. They gave me one song to demonstrate that science rap exists. And all this physics stuff is going to mix with neuroscience, and pretty soon we're going to start talking about free will. And as a rap artist who's been at this for over a decade, you got to get into freestyle. So I'm about to do a freestyle interpreting a lot of what was discussed for this last half hour. And I want you to think about this. Either every word they said and every word I'm about to say was predetermined since our Big Bang on our slice, or there is some kind of free will possible. All right, hit it. Now, I'm from Western Canada. When I was a young rapper, picturing myself on MTV, this is the rap I always picture myself kicking. Listen to this lyric, it isn't freestyle, it's written. I wrote it of my own free will, it was my decision. Every intimate constituent, part of it was deliberate. I considered how to script it and how to stand and deliver it. I wanted to get up on stage and do a lot of damage and talk about how all the universes were like a big sandwich. And I could just step up here and do some things that are drunk on beats and find out why astrophysics makes people feel hungry. That was forethought, but that doesn't mean nothing comes before thought. Look at the source of your thoughts. You might find the doors blocked if every decision is made in a part of my brain that's invisible to me. That's will, but with a subliminal origin. I'm not thinking it's too free. See, I break it down. I show you the freestyle basics. You can't see me. All you can see is the imprint of my radiation. See what I'm saying? That's the way that I spit it with freestyle bars. Looking for me is looking for in the universe the first star. But what am I doing here? Why am I choosing to bust the rhyme? Am I a puppet on a string who could not have done otherwise? A slave to my subliminal amygdala reptilian forces with no self-control. Up in my neocortex, I can't stop. I'm stuck here trying to bust raps. I could no more stop than Neil could shave off his mustache. I'm trying to figure that out. Maybe perhaps it could happen, but we're all stuck up in this quantum bubble bath. I can't stop believing in the option to choose. I couldn't stop if I wanted. It's down to the molecules. I choose words and deeds, not wants and moods. Freedom is like a muscle, it's only strong when it's used. I can't stop. Well, I probably could, but I probably shouldn't, cause right now I gotta kick a rap and make it really good and maybe interpret everything that they talked about a second ago. Alright, let's do a little rewind. Y'all people could be checking the flow. See, I'm gonna drop this and say everything clearly. I'm 5 years from stardom, like Brian explaining string theory. It's about to happen, any second is coming next. Every word I spit is peer-reviewed, something you can check like the literature. It's a freestyle now as I spit it at you. Indeed, that's the place that I take it, breaking down the basics. Yeah, check it out. Freestyles, people always felt them. I'm gonna get on the Big Bang Theory so I could get dissed by Sheldon. Yeah, one day that's about to happen. That's the cameo. Baba Brinkman coming through right now with nothing but a damaging flow. Yeah, check it. I'm gonna have to come sparking it. I'm cooking. It's not gonna get the same reaction as it did with Neil when I say, is there a house full of Brooklyn? No, I screwed it up. That's okay. I'm just blazing them. That's the way that we say it where I come from. I'm Canadian trying to bust the rap, so I'm gonna say a shout out to the plaid shirt right there. Me and him are repping the lumberjacks. Can't stop believing in the option to choose. I couldn't stop if I wanted. It's down to the molecules. I choose words and deeds, not wants and moods. Freedom is like a muscle. It's only strong when it's used. Well, I could stop. I could stop if I want. The question is, why would I want to stop? I could stop, it's just not recommended. At least not till this song is ended. Cause I spent a lot of time training my brain to rhyme at the drop of a dime. That's the kind of freedom I could claim as mine. Freedom isn't a metaphysical state at the level of atoms. It's a collection of talents each of us can develop and manage. Freedom evolved. Evolution gave us the building blocks. Absolute freedom, maybe not, but more than a digger wasp and more than prefrontal cortex lesion patients living today. I'll take the freedom I've got over the non-freedom of Phineas Gage. Freedom is having a brain that can reject options, detect imposters, dodge sucker punches like boxers. Freedom is having a brain that can navigate obstacles in a continuous exploration of the adjacent possible. A brain that's free enough to recognize goals and pursue them and recognize the reasons why, even if it's prone to illusions. Freedom. If you've got that kind of mind and it's at fault, congratulations. You can now be tried as an adult. Free will. It's similar to freestyle. It's a learnable system that's deterministic deep down. But even if every syllable has a physical cause, freedom is just the belief that I should still get some applause. Thank you.
Oh my God!
Well done.
Oh!
Fantastic, man.
Oh! Oh!
Right, so Baba,
Oh!
so what part of Harlem were you from?
Do I say that?
139 in Lenox, that's the danger zone.
No,
Could you tell by the way I said, is the house somewhere around Brooklyn? Or?
Yeah. Brooklyn in the house. Right. So you're actually Canadian.
Yeah, I'm from Vancouver.
That's just a little creepy, I think. I don't know. It's good, but I think it's the universality of the medium that I think it's speaking to us all. Where you want to express yourself, it comes out. It comes out just how you feel it in that moment.
The question is, if you imagine hip-hop culture spreading to Western Canada and then getting adapted and coming back to Brooklyn, would you imagine it sounding any different than what I just did?
Yeah.
So
All I know is this: I can't be black anymore. I'm gone.
So you got to run, because where do you got to be?
Okay, so that was a piece from an off-Broadway production I'm doing, hip-hop theater, very inspired by Hamilton. It's called The Rap Guide to Consciousness. And it's all neuroscience, cognitive
And you're
psychology.
performing that tonight. You got to leave here tonight to perform that.
The show starts in 45 minutes.
Well, get the hell out of here at the Soho Playhouse.
Soho Playhouse downtown is running until the end of April. I hope y'all can come see it.
Dude.
Thanks for having me here. I appreciate it.
Love you, man. All right.
Thank you, Neil.
Baba Brinkman. So
that guy's my favorite rapper now. Jay-Z, suck it! I ain't never heard Jay-Z say anything about his prefrontal cortex.
there's some good vocabulary running down there.
That was serious, man.
Just to be clear, he did that in rehearsal.
Yeah.
And 5% of it was the same. The rest was completely invented in that moment.
Yeah. It was
Plus
unbelievable.
the dude talked about my mustache.
See, he knew better than to do that in rehearsal.
Our next segment is going to be StarTalk All-Stars, where I take a back seat and we bring on the host, one of our many talented StarTalk All-Stars, neuroscientist Heather Berlin. Heather, come on out. Hey. So, Heather, is your show.
Okay.
Go for it.
All right, Neil, you can take a back seat and
I don't think so.
You don't know me very well, Brian. You don't know me very well. Welcome to StarTalk All-Stars at BAM. I'm your host, Heather Berlin. I'm a cognitive neuroscientist. I'm based here in New York at the Mount Sinai School of Medicine. So, Neil, Brian, thanks for being my guests tonight. And we're gonna...
And Chuck, forget about you.
You're just ingrained in my mind. We've become one. We've become Chuck, my co-host, for bringing all of the wonderful scientific insights and comic relief. Thank you for being here.
So wonderful of you to say.
So we're going to talk a little bit about the intersection between neuroscience and physics. We'll talk a little bit about consciousness, time, and free will. So we're just going to keep it light. Light and easy.
Free will.
Yeah. So
Not Free Willy. Right. Free will.
it's not that kind of show. We are going to...
That was a movie.
I took that reference differently.
That was a movie.
You know what's funny? I was thinking that. And I was like, nah, I better not say it.
I told you, we are one. You're like my subconscious that I just kind of try to keep at bay, but it keeps coming up.
That's a very good plan, actually.
Yes. So actually, Brian, you once tweeted, you said, free will is the...
Wait, you're going to quote a tweet of
I
mine
am quoting
in
a
front of this
tweet.
guy over here? That's like saying I play baseball in front of Babe Ruth, right? It's like saying I write music in front of Mozart, right? All right, go ahead.
Your tweets matter. Your tweets matter.
Thank you.
Free will.
All tweets matter. Yeah.
Not all tweets. Not all tweets.
Blue tweets matter. I
We
had
got
to do
some
it.
red
I'm sorry.
tweets in the house. We got some red tweets in the house. Okay, so you said free will is the sensation of making a choice. The sensation is real, but the choice seems illusory. Laws of physics determine the future. So
I had to say that.
you were compelled. It was determined from the Big Bang. What does physics have to say about free will?
Well, it's not definite because we don't fully know the laws of physics, but the laws of physics that we currently have at our disposal have no opportunity for intercession by human will, right? I mean, we are a collection of particles governed by laws that you can write down and fit on a t-shirt, and those laws don't at any point in the evolution of the particles say, hey, can you tell me now what to do, person? Mm-hmm. They just determine the future based upon what things were like in the past.
But Brian, can't there be an emergent property of that collection of molecules that we can call free will? Just because the emergent property, if you know emergence, it's a feature of an ensemble that cannot be deduced by the study of the individual.
Like ants.
Like ants. You study one ant, you say, hi, ant, you'll shake your hand, you have no idea that 1,000 ants together are going to make an ant mound.
Right.
Or 1,000 termites make a termite mound.
Right.
Or that birds will flock. You have no way to predict
the idea
that.
is
That one ant sounds like Woody Allen.
If free will doesn't
Forget
exist at the level of physics, in other words, if it doesn't exist at the level of physics, could it not exist at the level of biology or, say, psychology?
That's right. So it's a very good point, and it really depends on what your definition of free will is, right? Normally, the intuitive definition is things could have been different, and I could have made a choice for things to turn out differently. And if that's your definition of free will, does that resonate with your perspective of free will? Then I don't see any way to square that with the laws of physics, because anything that you do is your particles executing some kind of motion, and the motion of your particles in your brain and your body have no opportunity to allow you as a conscious being to direct them. What force could possibly that direction come from? Is it the electromagnetic force? Well, that one we understand from Maxwell. Is it the gravitational force? We understand that one from Einstein. Is it the nuclear forces? Those we understand from the standard model of particle physics. What force could you possibly exert on your particles that goes against or goes beyond those that emerge from the equations of physics? That's the issue.
Could our free will thrive in the probabilistic description of quantum physics?
No. Not as we currently understand it. And that's a natural
Don't
place.
make me fight you here on the stage.
Well, we've done this before.
Yeah, we did actually. Yeah, I grabbed his lapel on stage once.
But we both were wrestlers in high school. Different weight categories.
Yeah, very different weight categories.
So it's I should have said it's possible, but I consider it highly unlikely. So there is a puzzle right now in quantum physics that has been on the table for 50, 75 years, and we don't know the answer to this puzzle. And that's why I have to couch my remarks with a little bit of uncertainty. And that puzzle is this. Quantum theory says that you can only predict the probability of one outcome or another, right? 50% chance electron here, 50% chance there. Yet when we measure the electron, we always find it either here or there, right? One or the other. So how do you go from the fuzzy probabilistic haze of many possibilities to the single definite reality that we all experience in everyday life? We still don't know how to bridge that gap. So within that, if consciousness somehow plays a role in picking out one outcome from the probabilistic haze, then sure, then free will might come for the ride as well.
There you go. You just said probabilistically, the particle can be here or there.
Yes.
But if you measure it, it is only in one place.
Yes.
So my act of thought is I want a cheeseburger, that's the particle in this state. And I'm gonna say, I want a cheeseburger, bam, the particle's there.
Wait,
that's the part I don't buy right there. You see, because...
Why are you poking your foot?
Because it's random. There's nothing that you did to pick one outcome because you wanted it, because you willed it, because it was your desire. And yet your intuition is you had the cheeseburger because you chose it. If it comes from a random process, it's like throwing the dice. And throwing the dice to get an outcome is not what we mean by free will.
Okay, wait. You physicists.
Sorry.
I'm going to give you a neuroscientific perspective.
Oh, good.
Okay. So from a neuroscientific perspective, first of all, what's happening at the quantum level doesn't really scale up to whether a neuron fires or not, right? I mean, that indeterminacy. But from experiments that we've done, starting in the 80s, Benjamin Libet did studies where he said to somebody, whenever you feel like it, just press this button. And he measured brain activation. And he said, even before they actually press the button, because that takes time to make the movement, just let me know where this little dot is on the clock when you feel the first inkling of the intention of wanting to move. And then what he found is about 350 milliseconds before a person even had that conscious intention, there was a gearing up of brain activation, right? So then, leap forward to current times, we do neuroimaging experiments where we can say to a person...
Just so people know,
Yeah.
you measure people's brains for a living.
That's my job. That's what I do, yes.
Okay.
I would be no help to you.
It's my unconscious here again. He's always butting in and, we need you. But you can measure using fMRI, which looks at blood flow to different parts of the brain.
Functional
magnetic resonance imaging. Basically looking at blood flow as a proxy to neurons fire. The blood is going to go where the neurons are firing because they need energy. So we can say to you, okay, just choose left or right, or that hamburger or not. And
Cheeseburger.
Cheeseburger, sorry, that's a cheeseburger.
He chose to put cheese on that burger.
We can predict up to 10 seconds before you even have the conscious inclination of your intention which you're going to go, left or right, or cheese or no cheese, right? So at that level, I like to say, yeah, sure, we have free will, but we're just not conscious of it, right? The brain is making these decisions all the time, and we have this illusion of free will. But the question really is why do we have this illusion? Why did we evolve this illusion? Is it important? If we didn't have it, would it change our behavior?
Yeah, I mean, it strikes me that it gives us that sense of control that presumably out in the savannah, 50,000 years ago, 100,000 years ago, made the difference between surviving and not. If you're invested in how things turn out and feel that your decisions can affect how things turn out, you're more attentive, you're more engaged. It's something that matters to you more, and presumably something like that or some parallel story like that suggests why we have this illusion.
So you're less likely to be eaten.
Yes, that's the
Right.
point. That's the
Right.
point.
Well, so you both agree with one another, with each other, that from physics point of view, it's deterministic. You didn't use that word, but I'm putting it in your mouth.
Mm-hmm.
Okay.
It's okay.
Okay.
Yeah. I mean, it's okay on the radio and live show, but
Right. So
Yeah.
Heather, so your results are consistent with his, basically.
Yeah. I think from both a physics perspective and a neuroscience perspective, we come to the similar conclusion that it's an illusion, that free will is an illusion, even though we really feel like it's not. And actually, studies have been done, which when you tell people that free will is an illusion, and you start giving them subsequent tests, they're more likely to cheat on a math test. They're more likely to act unethically. So the fact that we have this belief, those who have had it actually are better able to survive in the system along the line.
We're more likely to behave.
We're more
we
likely
think
to
we're in
behave.
control.
However, we also have evolved for there to be cheaters, right? And they can win. And so if we were all cheaters, no one would win. But if we all...
Just ask Tom Brady.
And Chuck, he looked so deflated at the end of that game, right? He was sad. So, Heather, is there let me ask you a blunter question.
Right.
Does it even matter that you know this, if we all feel like we have free will? I want to believe that I go to school and get a good job and behave, and I want to believe all that.
Well,
Are you telling me I shouldn't believe it? That if one day I end up in prison, that was predetermined from the Big Bang?
And wait, just
You're saying yes to that?
But wait,
Absolutely,
as an addendum to that, as an addendum.
if you're going to do it, you're going to do it. There's nothing I can do to stop it.
So if I kick your ass right now,
That's it.
that was
Then
predetermined
it was meant to be.
from the Big Bang.
It was meant to be, my friend.
I don't know how this got so sexy.
Plus, Brian, kicking one's ass is not a literal stick your ass in someone to kick.
Well,
But wait,
From the hood, it means just winning a fight.
Oh.
But that
Actually,
predeterminism.
Brian was born and raised in New York City. So went to Stuyvesant High School. So he's homegrown.
Oh, nice.
Homegrown.
But wait, that predeterminism that you were just talking about. Okay, let's say, for instance, that you do accept that, and then that leads to fatalism. Was that also predetermined? So the fact that you were given this information that, well, I'm not really in charge of my own decisions. My brain is making these decisions based upon these neurosynaptic transitions that happen within my mind. And so I just let that happen. And then I say, okay, because of that, I don't give a damn about anything. And I just let it all go. Was that predetermined?
Yep.
Well, there you have
about
but
it.
also to put it in perspective.
Sorry,
Well,
man.
okay. God, I'm going to shoot myself tonight.
But you
Wait,
see,
I gotta just let the record show. Chuck put out a really awesome question right there, and it just got a one-word answer. I know. You could have at least stretched out your answer. Give a guy a break. You
No,
know?
happy to. So often people, when they encounter these ideas, and you must have heard this too, people say, okay, then I'm not going to do anything. I'm going
Right.
to sit on my couch, and what does it matter?
Fatalism.
Right? But you see, that's a mixing of two distinct views on one question. You see, if you think that you're making a free choice to sit on your couch, then you feel like, well, now I am going to give in to this, and I'm just going to sit there. But if you do that, it was determined. So exactly what you're asking. If you choose to sit on your couch, it's not that you made a volitional choice. It was set in place. And if that's what was going to happen, that's what's going to happen.
So, but then by that particular measure, all information that we receive then predetermines everything that we do. That's really what you're saying.
Yes, absolutely. And moreover, but to just give this a little bit more color, I think your view, Heather's view, and Baba's
Don't
view.
mansplain her view.
Okay, I won't that. But what I heard Baba say.
Now let me tell you something,
Hang on,
Brian.
hang on,
Let
hang
me
on.
tell you something.
Yeah.
I predetermined to say that.
We spoke about this before we came out. But Baba's description, I think, really at least helps me when I think in those terms, which is it's not that free will is the intuitive one that we're talking about here. Free will really is the fact that we're able to carry out this amazing spectrum of behaviors. We can walk, we can talk, we can sing, we can come up with ideas. The fact that they had an earlier cause, maybe even back at the Big Bang, to me, it doesn't take anything away from creativity. It doesn't take anything away from originality. It doesn't take anything away from having a sense of authorship over your own actions, because you're the most immediate cause of those actions. They emerge through you, through your particles. Your particles in your brain are configured in such a way that when certain stimuli hit your body, you said and do certain things. The fact that it's determined, who cares?
So there's different views of free will. Okay, there's not just determinism and non-determinism. There's compatibilism,
Which is what that is.
Yeah. And compatibilism is saying that the world, it is deterministic, but we also have free will within that because of these probabilities. And the other question, getting kind of to what you were saying, is that, so then people throw their hands in the air, okay, if there's no such thing as free will, then I can do whatever I want. I can go murder someone, it doesn't matter, it was predetermined. However, we have also
However, Chuck.
evolved.
There's a
There is a
there.
however, that's
That's
really
it.
important. We have evolved the capacity to have self-control as other animals. But in particular, we have the largest percentage of prefrontal cortex than any other species, which is the part of the brain that has that ability to control our innate impulses. So we hold people accountable for their actions to the degree to which they have the capacity to have self-control. Therefore, children are less responsible for their crimes than adults, or people who have prefrontal lesions or severe psychiatric illness. So
Because children don't have a fully developed
prefrontal cortex
yet.
until about the age of 25.
And
So
for guys, it's 35.
yeah, it's a little bit, push it out a little bit more.
Or perhaps 70.
Let me ask both of you something, because you both have to think about this. Since we're talking about the brain predetermining something you do, you're talking about the Big Bang predetermining all future events, then is the fact that we experience time, is that itself an illusion?
I'm going to say yes, time is an illusion. the way we experience it. Now, I'm not talking from the physics perspective, right? But the way humans experience time is an illusion because it's very easily manipulated. So for example, in experiments, we can take something called transcranial magnetic stimulation, which is basically transcranial magnetic stimulation. You put a magnet and you can kind of zap different parts of the brain and temporarily knock them out.
People let you do this to them?
We do all sorts of things, Neil. Why do you think I became a neuroscientist?
I gotta be honest, I'm kind of up for it.
It's a lot of fun. It's a lot of fun.
It's just that, Heather, you describe it with such glee. Stick a magnet on their head. Okay, and what happens?
One day I'll bring you into the lab, Neil. It'll be a lot of fun.
I have the magnets in my head.
Yeah.
Okay.
So we can manipulate. For example, we have you do an action. Like you can press the button whenever you want. Kind of like that. Let me know when you had the intention to do it, and then we see when you do it. And then we zap you just after you do it.
Zap you.
Little magnet stimulation, and then what that does,
it's innocent.
Harmless. It's harmless.
Magnetic stimulation of the brain.
Absolutely harmless. Yeah. And what it does is we can move back in time your perception of when you had the intention. We can move forward in time your perception of when you did the action. Okay, so that's one way we can manipulate time. You can manipulate time when you're in various different states of consciousness. When you have particular types of brain damage, especially to the prefrontal cortex, your perception of time will speed up. We're starting to understand what parts of the brain are related to time perception, and when they're damaged, your time perception changes, or when you have certain psychiatric illnesses. Even during the creative state, when you're in that kind of flow state, like when Baba gets into his flow and he's rapping, I've looked at his brain in the scanner and other rappers.
He let you do this.
Why do you think I married him? Oh, he's my husband, by the way. Full disclosure.
Wait, did he know before he married you that
No, she made him marry her. They were out at dinner. She was like, come here, I'm going to put a magnet on you.
The real question is...
Don't try to dodge this fact. We know. All right.
The real question is, did he write a rap about neuroscience because he married a neuroscientist, or did he marry a neuroscientist because he wanted to write a rap about neuroscience? Ooh. We'll never know.
Now, listen.
I digress.
Now, I'm going to tell you what I know, and no disrespect to Baba or my wife of 20 years, but he married you because you're hot. Now, that's one thing that every man is predetermined.
He tells me he was more attracted to my brain, but I'll leave it at that.
And I'm going to tell you, he's lying.
So anyway, as I was saying, I put him in the scanner. Yes.
You put him in the scanner while he's rapping.
While he's rapping. And we actually found a distinct pattern of brain activation where during the improvised state versus when he's doing a memorized rap, he gets decreased activation of the part of the brain called the dorsolateral prefrontal cortex, which has to do with our sense of self and time and place. So when you're in these flow states...
There's actually a part of the brain called the dorsolateral
right,
prefrontal.
Right.
Could you make up your mind where this thing is in the head?
I'm kind of with you because it's like dorsal, lateral, prefrontal. Right. It's just like, so exactly where is it? It's all around here. It's like all up in here.
In this exact spot.
It's right there.
Well, you know,
okay, I'm
there
sorry.
are a lot of parts to the brain that we need to describe in exquisite detail. I won't even ask you about your physics terms that you all use. So it's turned down, right? And then, so that's why when people are in this flow state, it feels as if it's coming through them from someplace else because they lose their sense of agency. But they also lose their sense of time. And we also know in people, if you knock out with transcranial magnetic stimulation that part of the brain, it'll affect their perception of time. So time is a creation of the brain. It's an illusion, just like anything else. And the other interesting fact is that people without any brain damage, just healthy people, actually have a slower subjective sense of time than the actual clock time. So we're not very accurate at telling clock time. So we have our own kind of internal pace.
When I was a kid, I did a really geeky thing just because I could. I trained myself to count seconds precisely. And...
Oh. What are you talking about, Neil? That's not geeky at all.
And my personal best was I counted 89 seconds when 90 seconds had passed. And I used to do it with stopwatches. I almost got an applause for that thing. One other, and so Brian, I was trying to match real time.
Yeah.
But she's saying it's like, the brain can be manipulated to think about
is there such thing as real time? I just think it's an illusion that we experience, but is there actual real time?
From the standpoint of physics, there is a conception of time because that's what allows change to occur. So when people say from a physics standpoint that time is an illusion, I don't really know what they mean. But it is the case that our experience of time, which you say that you can manipulate, which is quite interesting.
With magnets.
Yeah, exactly. Our experience of time does not give us insight into the way time actually works. Because once you learn that time for me is not the same as time for you, if we're in motion or if we're experiencing different gravitational fields, these are measurable differences between how your watch and my watch will tick off time based upon what we're doing and where we are. That's counterintuitive. We've never experienced that. It took a genius of Einstein to come along and reveal it. So I would say that our experience of time gives us a misrepresentation of how time actually behaves. But time is real.
But for every one of us, we are prisoners of the present, eternally transitioning from our past to our future.
Jesus. Wow. Man.
That's deep, man.
Man,
we should just end the show right
there, man. You said that, I was like, I guess we out of time.
Well, there's actually, looking into the future, there might be ways that we can do things now, like implant electrodes in the brain, right, and stimulate certain parts
The more
directly.
you talk about this,
well,
we can plant electrodes in the brain because the magnet wasn't good enough.
And to boot, we can control it with remote control. This is real stuff. I promise. Wait, Neil.
How do we know, Baba, you weren't just off stage controlling Baba like this with a remote control? How do we know?
Why do you think he was so good?
Dang.
But if we could, and theoretically we could do this in the not too distant future, go in and implant electrode and affect your perception of time such that every moment appears to last an eternity.
Depends on which the moments are, man.
Well, you can fast forward the ones you don't like. Yeah. You can keep the really good ones.
Wait, that was in Black Mirror. I saw that in Black Mirror.
Yeah.
I was going to say, have you been talking to my wife?
But the question would be, would you want that implant? Would you want that? Because I happen to think that, having to experience both the good and the bad, but the fact that it's temporal and that there's this limit and that it's our most valuable resource gives life meaning.
But suppose you could find the moments in time or the places in the brain where you're most creative and then make that be your most sustained experience.
Well,
does creativity map into this conversation?
Yes, when you're creating, the parts of your brain that are normally active when they're clicking off time are down-regulated when you're in that creative flow state. So time doesn't seem to exist. Self doesn't seem to exist. It's a very pleasurable state. People strive to get there.
I bet Brian and I could agree on this. When you're cranking out some equation, you forego personal hygiene. You don't know that you're hungry. You don't know because you don't know how much time has elapsed.
And you almost
Brian,
feel
you
like
agree?
Yeah, I call that Sunday.
Yeah.
But you also it feels as if you're tapping into something greater, as if you are outside something greater than yourself, because your sense of self is turned down. So in those moments, I would argue that we feel eternal in a sense, because time is not existing. And it is very pleasurable, but do you want to be in that state all the time?
Well, if I had control over it, do we have control over it?
If you had control, you potentially,
if I had
we can give
control
you
of it.
control.
Yeah, she wasn't very sure about that part.
Yeah.
You have control. All I know is this: I am never coming to your lab because you like a real life version of Get Out. Lay me down on the table and just now sink it to the floor.
Well, I welcome any of you
No,
into my
no,
lab
no.
at any time.
Chuck and I
It's
are walking
an
right by.
open door policy. Come on in. But yeah, so anyway, I would argue that our sense of time is what gives us meaning. And there are some patients who get lesions where they are just literally living in the moment. They cannot see the future and they cannot think of the past. There's someone who has a certain type of
So
brain
the
damage.
prisoners of the present without vision.
Right, see, because you say we're prisoners of the present. I say we're not prisoners of the present because we can see into the future and the past. There are true people who, there's a man, he had a certain type of brain damage where every minute he keeps a diary and he just keeps writing, I am now just conscious for the very first time. Right now I'm just conscious for the first time. Now I'm just awake the first time. And it's just each minute because he has no vision. He can't look in the future and he can't see the past. It's only the now. He's a
Which
prisoner.
magnet made that happen?
No, that was the type of brain damage that we
And
don't
can I
want.
borrow some money from him?
Chuck!
Wait, one interesting thing of that story, though, just to give it meaning, he had damage to his hippocampus, which is involved in memory. But the one thing he did remember.
There was
that
an
remained-
episode of Family Guy called Big Man on the Hippocampus, by the way.
Really, I've never
Yeah.
seen it. Well, the thing that stayed
I know because
constant.
I was in that episode. That's why. Yeah.
You were the big
Or it's
man.
referenced in it or something.
You were the big man on the hippocampus.
No.
Oh no,
I was
wasn't
just,
you?
Yeah.
The thing that remained stable, though, is every time his wife would come to visit him, and this was over the course of years, he would recognize her and see her like it's the first time he's seeing her in a million years and say, oh, it's so good to see you. I'm so happy to see you, whatever. And that lasted for years and years, and that was the only thing that remained constant. And the other thing was that he was a professional pianist, and whenever he'd get in front of the piano and get into this mode, he could actually just play a whole piece.
Now,
And
was
those are
he
the two
aware?
things.
Was he aware that his wife was putting magnets on his head?
If only. But the one thing is this: we control the electrodes right now. The question is, can you control them yourself?
Yeah.
That's why I hesitate. We haven't got to that point yet because you don't want people going home
call
and
me
just
when you get there,
zinging
you know,
themselves, But,
Yeah.
but when we get to that point, then
Yeah.
I'll give you a call.
And so, Heather, we're about to lose Brian out of
no.
this segment before
Forever?
we go to our sports segment.
Forever,
We're about
she
to
says.
lose Brian.
So, Brian, do you have any sort of concluding reflective thoughts?
No.
And he freely said that.
So, Brian, I like, what was it, Einstein or John Wheeler, who said of time is invented to make motion look simple.
I hear Wheeler said time was invented so that everything doesn't happen at the same moment.
Oh. You can spread it out in that coordinate system.
And Einstein said that the distinction between past, present, and future is only an illusion, however persistent. And on that, I'll leave. Thank you very much.
Brian. Brian Greene, everybody.
Great job. For those of you who are uninitiated, Playing with Science is a sports science mashup where Neil likes to say where jocks and geeks collide. And I like to say without any concussions by the geeks. Because, when jocks and geeks collide, only one person suffers in that collision.
Yeah, one person walks away.
One person walks away, the other one does not. And normally,
By the way,
go ahead.
In high school, I was a geek jock.
A geek jock.
Yeah.
Yes.
Yeah.
So,
Yeah, you were a wrestler.
Yeah. So, but I intellectually I associated with the geekiverse.
Right.
But anytime I saw a geek sort of get beaten up or bullied, that was my sort of superhero. I would like, the geeks need me, and I would go and I would just, so I felt this urge to protect the geekosphere as a high school
What's
kid.
the superhero name for that?
I don't know. I don't know.
Chuck?
But it needs one.
Yeah,
think.
yeah, I feel like that-
I believe it's the Tysonator. Well, that's very cool, man.
So who do you have?
So, but before we get into our guest, who is just so awesome, actually, I'm going to use a different word, who is such a superb guest.
He said that because anytime I hear him say awesome, he said it would be awesome if you could pass the salt. And I would say, when I grew up, the word awesome was applied to curing polio, walking on the moon. And there's a next generation that has no concept of how to use that word.
And I blame the Lego movie. You didn't see it.
No, I didn't see the label.
All right. Everything is awesome. Okay. Okay, let me just say, first of all, I can't tell you how long I've been waiting to do that on stage. But normally this show is co-hosted with Gary O'Reilly, who is a former professional soccer player and the co-host of Playing with Science, and he is currently a broadcaster, and he resides in the UK. Unfortunately, his flight was canceled, and so he could not be here.
It was snowing in the UK.
It was snowing in the UK.
Yeah.
No, it was snowing here, and unfortunately, he could not be here. So but he is listening right now, not right now, but he will be listening to this broadcast. So if we could all give a round of applause to Gary O'Reilly.
Gary?
And so what we do here is we explore the science of sport. And to help us do that today, we have an incredible guest who is a former Olympic silver medalist. And she is also, wait, how many times was it? Oh God, I gotta look at these notes because I want to get it right. 5-time world champion medalist. Please welcome the incredible Sasha Cohen.
I'm so excited to join the fun.
Oh, it's so great.
Hop over here.
Excellent.
Have a seat, Sasha.
Wait, Chuck, what did she get her medals in?
Thank you, Neil.
That's okay.
Yeah, the truth is that I took it for granted that everybody would know because you're Sasha Cohen, but she is a luge. I said luge. Sasha, of course, is a figure skater and a damn good one. And not just a figure skater, because you're also an incredible ballerina and gymnast. All of those things like rolled in and then strap skates on and do it all.
Exactly. I started in gymnastics. I wanted to take hip hop. My mom directed me towards ballet for skating.
That's because she wanted you to have a job.
Exactly.
Hey, what are you talking about? What's wrong with hip hop?
Don't worry, your husband is still my favorite white rapper.
White science rapper.
But go ahead.
So that was how I got started. I started in gymnastics because I was basically a bundle of energy and I destroyed the house. And they're like, how can we calm you down? So I got put into gymnastics for about 3 hours a day, every day. And when I was 5 years old, I was doing like hundreds of jumping jacks, push-ups, V-ups. And when I got home, I was a very well-behaved child.
V-up, is that this here? What's
Are you
a
going to
V-up?
show me?
Oh, this? Is that a
Am
V-up?
I going to show you?
No.
Yeah.
Okay.
So
I
you're
just didn't know.
basically like
Okay.
this, and you're like going up.
Okay,
like that.
cool.
Okay.
Very
There you
cool. Okay.
That's a V-up.
That's very impressive. I got to tell you, right? No,
Let
I'm
me
not.
see your V-up.
You know what? I'm good.
You're good.
You got it.
You do it later, Chuck. Later.
Yeah, we'll do that.
It
in a little bit.
exists in the space-time continuum. Just leave it there.
So we, of course, have Heather Berlin here, Dr. Heather Berlin, who is going to break down the neuroscience because there's a lot of neuroscience that goes into pretty much every athlete, correct?
Yeah.
Like when you talk about the brain and the discipline and they call it muscle memory, but it really isn't muscle memory, right?
It's actually called procedural memory. So basically, when you're first learning, and you'll probably have had this experience, the moves or whatever it may be, you have to really focus, and you're using parts of your prefrontal cortex. You need conscious focus, even learning to tie a shoelace for the first time. And then over time, over repetition and discipline to do it all those many times, it starts to become implicit or unconscious, and it moves into the basal ganglia, which is the sort of subcortical part of the brain, and it becomes this procedural memory or
Which is what we call muscle memory.
Yeah, and
Yeah.
it's like riding a bike. And then once you get it into that implicit state, if you become too self-aware of what you're doing, like, oh, exactly how should I hit that tennis ball or do that, it will mess up your flow. So I imagine that you practice it so much that when you go into a routine, you're almost going on autopilot, right? You want to get to that point at which your body knows what it's doing and you don't have to think about it because the thinking messes it up.
Because Yogi Berra said at baseball, 90% of the game is half mental. That's what he said. Yeah.
No, it's true, and I think that's where a lot of elite athletes get in trouble. And it's happened to me on several occasions. Is where you train your body to do something over and over and over, but then you have this one moment, and you're like, I can't leave it to chance. And so you get your mind involved because you also have days that you're only practicing an hour a day once you're at competition, and then you're just thinking about it over and over, and this one moment arrives, and it's very hard to put away the monkey mind because it really wants to be there to help you, but it's like too many cooks in the kitchen.
Exactly, and when you turn down that part of it's the dorsolateral prefrontal cortex that's
There it
making
is.
you
There it is,
self-aware.
Yeah, yeah.
And that's the inner critic, and oh my God, what should I do? And then if you can manage to turn that down and just enter into the flow state and lose yourself, that's when you really perform at your
Exactly.
best. Yeah.
You better watch Heather. She'll tell you to sink it to the ice. So, Neil, you yesterday, actually, I heard you talking to somebody at another thing we were doing when you were saying that you skate or you did something at the ice rink where you wore figure skates. What didn't you do? What haven't you done?
No, I spent the time in high school as a rink guard.
But not with hockey skates,
Not with hockey. I wore figure
which is
skates.
very unusual.
Yeah. The
very
rink guard is
unusual.
like a little more aggressive with hockey skates, but I had figure skates. Yeah, I had on figure skates.
Now, I'm just trying to figure this out, and maybe you can tell me.
Because that toe pick can hurt you.
That's why you had it.
Yeah.
You're
You ever
fierce.
see figure skates? There's like teeth in the front of figure skates. And so, yeah. There were some thugs who came on who were like
You're the real deal.
hockey thugs.
Who knew figure skating was so tough?
They were like, beefy, thuggy guys. And rather than fight them, I just challenged them to a race from one end of the ice to the other, and everyone parted ways. And they're having hockey skates. So they got to like press their feet left and right to go forward.
Yep.
I had on figure skates. I just went up on my toes and just ran. And I got to the end, waiting for them to come. So then they shut up after that. But so I deeply appreciate your craft. And
As a figure skater myself.
as a physicist.
We'll have to do the next episode on the rink.
Oh,
We'll race.
Oh, yeah. Oh.
We'll race.
Yeah. Oh.
No,
Okay.
those are
up
some
for it.
fighting
Take this to the
words.
rink.
Meet me outside on the rink with figure skates on in a tutu. Then we'll fight.
Are you
Exactly.
aware? Are you aware of the physics that because they call figure skating physics on ice? There's so much to it. Are you aware of the physics when you're skating, or are you aware of it at all?
I think you are aware of it, but you don't think of it in terms like of physics. The way that you define is like this like hyper body awareness, and you can feel when you take off for a jump if you don't have enough speed, if you slightly throw your shoulder too much, and you can feel in the air that you're off kilter and that you're going to go down hard. And you also know that if you're doing a single, a double, a triple, or a quad, exactly how much torque you have to put in when you leave the ice, because that is what determines like how fast you'll rotate and if you'll be able to complete, a certain number of rotations up in the air.
So torque is a force that sets something into rotation. And otherwise, it's just a force giving acceleration to an object. So you have force that goes in a straight line, and then you have torque, which is a force turning. So there you are. It's a force you are putting between your body, your skate, and the ice so that you can rotate.
To launch it, like
Yes.
to begin it.
Mm-hmm.
And the same with spinning, and that's something, you'll kind of go into a spin slow, and then you'll glide in and you'll ride the edge, and then you'll take the right side of your body and you'll snap it to begin the spin, and then you'll use your arms and legs to increase your speed or slow it down.
Oh my God! So all right, so I'm learning how to physics skate. Okay, so
physics skate.
Physics skate. That's right. I'm learning how to physics
Exactly.
Did you just
skate.
invent that word?
I did.
Physics
Physics skate.
Physics skate.
So here's what I would love to do. If for those of you who are listening and do not have the benefit of visual, because everybody is here, if you could stand up and just show us the actual, but you have to talk it through because people are listening at home.
Sure.
If you could show us the physicality of what happens when you're doing that motion, and then Neil, if you can break down exactly what's happening from a physics standpoint, I think that would be really cool. I'm making this up as I go along.
Wait. So Chuck.
Wait.
No, we do this. Wait. So we can pretend like we're we're the Olympic announcers. Sasha Cohen.
And this is what she's doing.
This is what she's doing. So Sasha Cohen, she's wearing high heels at this moment.
I am wearing high heels, but I've not done it this way before.
Okay.
So what happened?
So there's two instances, right? There's a jump and a spin. And I feel like if anyone's watched any figure skating, is somewhat aware of the difference. One, you leave the ice, and one, you don't. The jump, you leave the ice. So,
Chuck, you got that?
You know what?
Okay, well,
I'm keeping up.
You
we'll
with it?
start
Okay,
with the
stay with
jump.
this, Chuck.
So, for instance, like I will start with a sow cow. And so it's something where you're going to take off backwards, and you're going to be gliding on the inside edge of your left foot, and you're going to determine how much speed you want to get going in, right? So I'll be doing crossovers and running and going fast. And then I'll
Building
do
your
it-
speed.
Right. And then people have different entrances, but say like when many years ago, I did a quad sow cow, and I wanted to get extra torque. So I would do a turn ahead, and then I would set myself here, and then I would use the edge gliding backwards, the right side of my body, and I would dig in with my left foot into the ice and whip this up. And that's what would initiate the momentum. And I would leave the ice, push off this toe pick, and then immediately snap the weight over my right side. And based on how much I followed through with my right arm and right leg and pushed down with my left would determine how fast I would spin and if it would be a single jump, a double jump, a triple jump, or a quad.
Wait, can I ask you a question then? The way you just broke it down was a very logical, conscious, whatever. But when you're actually doing that, you're not thinking all those things, are you? Are you feeling them?
You feel it.
You feel it.
So
but
I
you're
think
not...
I'm explaining exactly what I feel.
Right.
But it's like you're very fine-tuned. You know exactly how much speed you need, and you know how much speed is too much that you'll lose control, that it could turn out great, but you have to get lucky because basically speed magnifies anything. It helps you get more height and more torque, but if you are 1 millimeter off in any direction and you have extra speed, you're going to go down really hard, or your alignment won't be quite right. So people are a little tentative with speed because that can, you can go up in flames. It's like putting leverage on your house. It can work out really well, or you can go bust.
Wait, but
Now finally something I can relate to.
No leverage.
wait.
Leverage
So
and
Sasha,
speed.
So go ahead.
so I get you gave a brilliant description of how you give yourself rotational inertia. Okay?
For a
But-
jump. We haven't even gotten to the spin.
But however, you didn't. Well, okay. So in physics, you generally break things apart into components, and you put them all together for the one thing. I break this apart. You told me how you gain spin, but if you're going to do a quad, you have to be airborne long enough to complete the quad before you hit the ground.
Yes.
So
That's part of it, because you'll notice if you've watched figure skating this past Olympics, you will see some people barely get off the ice and they can do 3 turns, and some people get this high up and they don't complete it.
2 or 3 feet off the ice.
So
it really is the rotational
it's
spin.
how fast you launch yourself up.
Gotcha.
And then obviously it goes into like, what's your body type? Do you have like wide hips? How fast are you spinning? And that's why men rotate faster and generally do a lot more quads than women do. They spin faster. They've got narrower hips. But women are more flexible, so we've got better spiral sequences.
How many women have done quads?
A couple have done it in practice, and I feel like maybe like one or two have done it in competition.
And you've done a quad.
I have. A long time ago. Thankfully, YouTube exists and it will always live there. I hope. I'll be like, wow, I used to do that. Now I just sit.
So Nick,
So people must have freaked out. I mean, did the announcer lose his shit?
It was
Excuse me.
an exciting
Excuse me.
moment because people can see when you get really close or you're double-footed or you step out, but when you actually do it and you come down from 4 turns and you have to have tremendous amount of strength and balance to catch yourself when you come down, get out, and so it's this moment where it's like, oh, is she gonna do it? Is she gonna do it? And you have it, and it's very exciting.
all I'm
This is the
saying is
launch.
it was exciting watching you just do
Yeah.
it in
Yeah.
heels.
It's an extra
So
layer.
there's the launch and the landing that both
Yes.
matter.
So when I trained, you'd work on explosive muscles for bounce, and then I would jump down off of boxes this high in order to kind of like learn how to absorb all that pressure and momentum coming down.
And you do that with the skates on?
With this, off-ice training, I do it without skates. And then on the ice, with skates.
Well, that would make Thanks, Sasha.
No problem. Just want to keep it clear. No misunderstandings. But then let me get to a spin, because a spin's very different because you're not launching yourself out. And it's something that goes for much longer. It's not fractions of a second. It's a spin, can be 30 seconds. It can be a minute. And you'll see most people wind backwards, and they're creating this. It's all about torque in the body. And this is why I realize I'm a terrible skier, because it's the opposite.
So they're winding the spring.
You're winding,
to send
right?
It out. Okay.
And so my hips are going to the left, and my shoulders are going to the right. A lot of abs.
Core work.
Yes. And then you step in and you ride this outside edge. And then again, you do the same whip momentum for a jump, except you don't take off, and then you spin. Generally, if I wasn't in heels, I could do more spins. And then once you're there, you'll keep this momentum, and then as I would bring in my arms and my legs, I can just insanely increase the speed of my spin. And likewise, if all of a sudden I wanted to slow it down, I would just open up, and you would see the rotations just kind of almost stop. And so in that way, I was aware of physics. But for figure skaters, we would think about it more in terms of like body awareness of where your hips are, what torque you need.
Plus, you have to look good doing it.
Yes.
Right, because you're being judged
And what color you look good in.
Right. There are other dimensions of the analysis of the rank of the scores.
Exactly.
Right.
So you actually, yes, can you tell us what is happening when she does that?
The physics, yeah. So if you, I'd take my shoes off.
I want to see your spin.
No, I'm just saying.
Wait a minute.
Just.
For those of you listening, Neil is taking off his shoes and putting on Sasha's heels.
Cinderella doesn't fit.
All I can tell you is this: Prince Charming is never coming back.
Thank you.
So in physics, here's the deal. So if you set yourself rotating, all right? So I'll do that right now, okay? So here I am rotating, okay? So that's at a speed. Wait, don't applaud yet. You don't know what's about to come, okay? So
you just spun around.
So you can calculate how much angular. So in physics, you might remember from your physics class if you had it or you. So everything that happens in a straight line, you can think of in a rotation. So there's a force. The rotational counterpart is torque. There is mass. The rotational counterpart is moment of inertia. There is, you also have momentum, and the rotational counterpart is just angular momentum. So here's the thing. Once you start rotating, your angular momentum is constant, okay? It's constant. So if I start spinning, and you calculate the angular momentum by, okay, here it is. It is the mass of whatever your body is.
Which in this case would be the biggest figure skater ever.
Here's the point. So your hands have a certain mass,
okay,
and they're rotating out at this distance. So you have part of your body mass away from your axis of rotation.
Oh.
Okay, so if you can calculate how much angular momentum that is. Now watch. If I bring any part of my body closer to my axis of rotation, then one of the terms in your angular momentum drops. So what happens is the distance to the axis of rotation drops, but your angular momentum stays the same, so something has to increase. Okay? So, because when you multiply these two numbers, you have to get the same answer every time, okay? So if I start changing the distance of the mass of my body to my axis, and I make it smaller, I have to spin up.
Nice.
And so there you have, allow me?
Yes.
Yes, ma'am, okay. So I will spin, and then Okay. And just like she said, because what she needs, right? Isn't that right? So you're spinning, you speed up, but then you can stop it by just putting your mass back out. So
Slow it down.
here's my proposal to you. Okay? Here we go. Okay. So put your arms out, okay? So you're my skating physics demo in this moment. So you have a certain amount of mass coming out here, all right? So
wait, for those listening, right now, Sasha has her arms
T-shape.
spread apart.
spread apart, yes.
And
Okay.
in a T formation, and go ahead.
Exactly. So there's a certain amount of mass along your arm and in your hands. And you also showed earlier, when you start a spin, you might start with your leg out, okay? And then when you bring your leg closer in towards your axis of rotation, you start spinning faster. And okay, so we got this. Oh, I like you have this is an infinity on your wrist. Very cool. Very cool. It's an infinity tattoo.
That is very, yes, that is an infinity tattoo.
Infinity tattoo, good. Okay. Sorry, I didn't mean it. Sorry. Okay, so here's my suggestion. I don't know if it's legal. Next time you do this, I think you can do a quint. Is there such a word?
There is such a word.
Good, quint. 5 turns. Now, how would you do that? I'm gonna say you get some lead weight to put in your hand.
Tom Brady all over again. Tom Brady.
Then
Tom Brady of ice skating.
So when you start spinning with lead weights in your hand, even if you're spinning at the same speed that you once were, you have more mass farther away from your rotation axis. So that as you then bring the more mass in, you will spin faster. And I don't know, people will notice if you're grabbing something, holding on to something.
What's going on?
So
Yeah,
maybe
as you skate
Metal
around,
gloves.
as you skate around the rink with 2 kettlebells in your hand.
It's a little obvious.
So what you do is,
Just
I
get
think you
really
can,
heavy rings.
yeah, that's what I'm saying. No, you
Really
can get
heavy
a
rings.
wrist bracelet and lead infuse the wrist bracelet, and it's just your jewelry.
And meanwhile, I build up huge.
So what I'm saying is, if you did that, the same gestures, you will spin faster. And you'll have to land, you have to figure out the landing. But but once you go...
I'm going to throw this back to you.
What's that?
For spinning, this would absolutely work, and it would give me more torque and momentum when I spin.
Yes.
But I think the extra weight would not allow me to get up as high in the air, and so even if I got extra torque when I pulled in, I would still not be able to rotate as
to
many
think
You
about
need
times.
to work on this. You
So-
need to work
so
on
it's a
this.
trade-off.
Yeah.
You have to think about that.
It's a good thing to think about.
You gotta think about that. So this is one of the interesting physics problems where there are 2 variables competing with one another, and you don't know if one is more powerful than the other, or where they meet to get the best combination of both. And that's where you get more interesting, complex problems in physics and in life.
I have a neuroscience problem here that I can
What's that?
address.
What's that?
You know, why don't you get dizzy when doing all of these? This
Oh,
spinning?
yeah. What's up with
Right?
that?
So I have an explanation for that.
'Cause Chuck, yeah, you know, Chuck, if we did that, we'd be like, you know.
Are you
Because
kidding
they're
me?
going around and around
I'm dizzy
and around.
right now.
So, you know, there's actually a neuroscientific explanation for that question.
So it's interesting for jumping. You know, it happens in a fraction of a second, and you don't get dizzy. It's just very quick. But spinning is something where ballet and skating really diverge. You know, if you're a ballerina, you're spotting, you know, like to the edge of the room, and that's how you're keeping, you know, your
And
awareness.
by
But-
spotting, you mean you pick a spot,
yeah, you pick
turn
a
your
spot
head very
and
quickly
you
back to
turn,
that spot.
and you turn.
That prevents you from getting dizzy
For ballet,
for ballet.
this is what ballerinas do.
Okay.
They always spot. But for figure skaters, you're spinning so fast, and you're not doing just like kind of one. You're literally doing, I don't know, like 50 turns. And the trick is you have to stay in the same center, so about like 1 to 2 blade lengths. And I don't know, I think it's like something to do with your inner ear, that if you're not traveling and you're staying in the same spot even though you're spinning, you don't get dizzy. But from personal experience, when you do a spin and you do a bad spin, which you get a deduction for, and you're traveling, so you kind of start here and I end up off stage,
That would be
you
bad.
get out of the spin and it's like a cartoon where you see the stars and you're just like, what, where am I? And so that's why they teach you have your center and don't travel. So explain that inner ear to me in like neuroscience terms.
I shall. So your inner ear consists of these 3 like fluid-filled tubes, right? And each one is at a different orientation, so it's meant to be sensitive to a different orientation. Let's say if your head goes up and yes, like this, or no, or side to side. And within those fluid,
These are the 3 dimensions
yeah,
of space.
the 3 dimensions,
Yeah.
and they're represented within your inner ear in these little these tubes. And within each of these fluid-filled tubes are these little hairs that are like sensing. It's almost like seaweed at the bottom of the ocean. So when you move, it senses and it sends signals to your brain. So if you think about if you're in a chair, let's say spinning, and you're holding a bottle of water, and you're spinning in this swivel chair, and then you stop, the water is going to keep going, right? Because it built up momentum. And the same thing is happening in your inner ear. So it's telling your brain you're still moving. That's why people get dizzy. And also there's
Well, that's why when you stop spinning, you fall over because you can't keep your balance because your brain didn't figure out that you stopped spinning.
it thinks you're still moving, but then there's also information. So there's information
Brain's
coming
so
to your
stupid.
brain from
Damn.
But your muscles are telling you stuff as well. There's proprioceptive input, and there's also visual input, right, giving you information.
What kind of
So,
input was the muscle input?
Proprioceptive.
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 Like proprioception. Yeah, proprioceptive.
Oh, that cleared it up.
I've heard that one before.
Yeah, yeah, it's proprioceptive. Like proprioception. We good now?
Oh, we good.
We're gonna move on. You're holding us up.
It's signals that tell your bodies its awareness in space. So your brain is getting that information from your muscles and your joints. The inner ear is telling you you're still moving, and your eyes are giving you information. So that's why they often say, and tell me if they say this too, when you come out of the spin, different than ballerinas who focus each time they make a turn, but you then are told to focus at a specific point because you want to have your eyes telling your brain, counteracting what your inner ear is telling it that it's still moving, that you're not moving any longer. And also what you do, I'm sure, is you practice off ice just spinning so that your brain can habituate. So it's not so much that you're spinning in one place versus moving, although the movement is going to cause it to be more confusing because there's moving in different directions, so it'll be less of a movement if you're in one space. But that's not what I think is happening. I think you habituate because you practice, right?
So your brain
That's
just
part of
becomes
it.
acclimated to spinning.
Yeah, only so much though, right?
Right.
Because it's still a physiological effect, right? So
And what you'll see
yeah.
figure skaters do is they'll spin very fast and then they'll slow down. And they slow down, they're kind of getting their bearings, you know?
And they're
So you're
readjusting
kind
their
of
brain.
easing yourself out of it.
Exactly. And then
Gotcha.
there's like a trick move that you do is you spin really, really, really fast and then you stop. And then you do it to the music. It's like, ba-bam. And then
it
you give
gives you a
yourself like a
moment.
second and then you're like, let me look at my arm now. And you just like, you have the choreography like you built in. You know, we have these like
That's
these
cool.
breathers
Tricks.
and
Wait,
moments
plus-
after a spin.
Well, Sasha, is it true that your fastest spin in any performance is the spin you end on? So you don't have to be graceful and balancy after that.
It's true. People generally do. They're more strenuous, like wham, bam, hit every position. It's like very dramatic at the very end.
Right.
Also because it takes up a lot of energy, and you want to get your jumping passes in earlier. Although you're seeing that change now a lot with the new judging system, where you're getting rewarded and getting more points if you jump after the halfway mark. But generally, you want to end on a big note. And so people will do combination spins where you hit like 6 different positions. You're in a camel, you're in a sit spin, you're in a layback, and then you're on the other foot and your legs up. So there's a lot going on.
Like a fireworks
It is,
finale.
exactly. It's a finale.
Yeah.
It's a fireworks
It's like,
finale.
yeah, it's just
You
like,
got
oh,
it.
put them all up there.
Come on. This one, that one.
Let 'em have,
Oh,
oh, yeah, look at smiley face. Oh.
everything you got. Throw it at the end. Exactly.
So, Heather, let me ask you this, because we are almost out of time. Why is it that, from a neurological standpoint, that is our first kind of foray into getting high? You see children spin around, and then they're just like, oh, I am messed up, man. Like, what is happening there?
Well, a lot of what drugs do is they kind of play with your senses, right? So normally we have input coming in from our senses, and our brain is organizing it in a certain way. But when you kind of mess with your senses and the way the brain is interpreting them, that's also what drugs tend to do. And it's interesting because it's a different brain state. You know, and it's not just your inner ear, by the way. Those inner ear, that information goes to that little brain in the back of your brain, the cerebellum, right? It's right in the back of your neck. And what's interesting is that has 2 times as many neurons as your entire brain, right?
Whoa.
2 times as many neurons. So
Twice.
Yeah,
It's two.
Twice.
2 times as many morons.
But it's unconscious, okay? And people who have complete damage to the cerebellum, they are still fully conscious and aware. I mean, they might have less coordination, they can't do triple axels and things, but they're fully conscious and aware. So we only need basically 1/3 of our neurons to have conscious awareness. But it's interesting how much goes into that ability to have balance. I think the reason why it feels good is that we like different sensations. We like to be outside of our normal, even dream states or creative states or daydreaming. When we're not in that normal state where the prefrontal cortex is on and everything's working properly, it's fun. It's interesting. That's why we like to go on roller coasters or rides that make us feel weird.
So Sasha, when you're performing, you're in an altered mental state, according to this. Was that?
Maybe that's why I became a figure skater. It's like the world is going to be too much.
The world.
Maybe that's why.
I need to skate for 20 years.
That's why you drink before competitions.
That was our secret.
That is it for Playing with Science. Please give it up for Dr. Heather Berlin, Olympic medalist Sasha Cohen, the inimitable Dr. Neil deGrasse Tyson. I've been your host for Playing with Science. Also, please give it up for Gary O'Reilly, who is not here. And our catchphrase is this: if you play with fire, you get burned. You play with science, you get learned.
Chuck you in the house. Woo! Bam! Get home safely. Have a good night, everybody.